Hello, my name is Dr. Ron England, and today we are going to talk to you about full stack development. This is part of COP4834 Web Systems II, and those people that are in that class know perfectly well that their aim for this class is going to be develop a full stack deployment of a web application. But let's first talk about what we're actually talking about when we talk full stack development. So in the world of full stack development, the first thing that you want to understand is what is the stack. And this is a pretty generic term here. When we say what is the stack, well, you're actually already familiar with the concept behind the stack if you've been doing any type of programming or engineering work, because you've used mobile applications, you've used web applications, you've been on Amazon shopping, you've played with, let's say, something like Netflix or Amazon Prime or those are all applications, and they're all web-based applications. They've got servers in the background. They've got something that may be a computer or something else in the foreground. The stack is the stuff in between, what's in the middle. So if we were just to kind of look at the stack from a very simple point of view, we'd be saying you got a front end, you got a middle portion, and then you got storage. And we can get that simple. There's a bunch of technology in the middle, which can be server-based technology or network-based technology that takes the stuff that's in that background that's stored, which can be data, it can be pieces of applications. And in the end, you got something that's in the front end that a user actually interacts with. And so at the very generic level, that is the stack. Now, you're going to need to go a lot more detailed than that because you're going to be a developer. You're the person that's in the middle that's actually the person that's actually putting all this stuff together. So let's kind of look a little bit deeper. So for this case, we can look at like an example of a typical stack. So let's say at the bottom end, over there, way over to the right-hand side, you got an operating system, some sort of like server operating system that's running on a computer that's out there on the internet somewhere in the cloud. More than likely, it's going to be a server that you've probably rented or leased, but it can also be something that you're running at your place of work. And on top of that, you might have a web server, a database. You may have some sort of database software on the front end of the database. And then between the web server and the client, you've got some code that takes what's on the web server and does some translation of the information and eventually puts out something to the client side. And at that browser level, and it doesn't have to be a browser, it can be an application that you wrote custom. It can be a mobile application, or it can be a browser front end. But there's this client-side code that basically that's the direct interaction with the user. And that client-side code could even have been generated by the server-side code. So there's a lot of complexity in here. But if you look at it and bring it down to its basics, you've got layers of things that do things that go from information on a server to the front end that a user sees. And we call that the stack. So let's get a little bit more specific here. Let's look at some of the pieces that might make up a stack. Well, at the operating system level, you might have Linux or Windows or Mac OS X or something like that. And you may have databases like MySQL, Oracle, SQL Server. There's a whole lot of Postgres. You've got other things that can be there. Web server, you might have IIS. You might have Apache. You've got code that translates files that are on that web server into something that the user actually sees that is then translated by a browser. But you've got these different types of languages that work with the server-side code like .NET or maybe PHP or Node. There's a whole ton of those. And on the client side, we kind of get a little bit more universal when we get to that client-side code. We've actually, the browsers, which are a lot of these things are translated in, typically work with JavaScript, CSS, and HTML, which pretty much most browsers, all browsers, can translate into some sort of actions that a user sees. So you're looking at a little bit more specific. But if you think about this, you, as a developer, look what you've got to learn here. You've got, well, just at a basic, HTML, probably HTML5, CSS, JavaScript, then some languages, possibly Node, which is a little bit more JavaScript involved, or PHP. In the .NET world, you can build in multiple languages, but more than likely C#, or I haven't even just started to go over the concept of Java and J2EE platforms, which are Java-based platforms. And then you've got to have a little bit of knowledge of how the databases work. Now, this may all be handled by different programmers. Every aspect. In large programming teams, you might be customizing, and you might be specialized in one piece of this. Still, reality is there's a lot to the stack. And if you're in my class, you're going to at least learn one line through that stack, how to program that in complete line. So for that concept of a full stack developer, if you're a front-end developer, bottom line, you know HTML, more than likely HTML5, full understanding of the document object model, DOM, JavaScript. I mean, becoming, if not an expert in JavaScript coding, moving towards being an expert in JavaScript coding, because pretty much universally that's what's being used. And also CSS, that ability to use the rich capability of a declarative language like CSS to do what you want to do. A lot of tools out there to help you out. There's a lot of libraries to simplify this. So if you're working in JavaScript, one of the tools that you've probably used in the past, one of the ones we use in the prerequisite courses for COP4834, jQuery. I mean, I just right off the bat say you really need to learn at least something. Bootstrap and jQuery are two that are right off the bat good ones to know. But you've also got other ones. And in the Web Systems II, you get to make the choice of what of these tools and libraries you get to use. Some people love React. It's a great it's awesome. Let's just put it that way. It's awesome. But jQuery is awesome built on top of JavaScript. The capability that something like jQuery gives you, and then libraries that rely on jQuery give you, are awesome. They make it easy to do things that you could have done before, but they would have been extremely difficult to do. Now they become easier. So should you use these tools? Definitely you want to use these tools. You want to make your life of programming the applications and the maintainability of the code become easier and easier. Downside, they may release versions that may make things that you've built in them not work anymore, which means that you've got to deal with the concept of code maintainability. Well, guess what? That's just the life of a full stack developer. It's one of the things we deal with. You just have to deal with it. Now, on the server side, which by the way, COP4834 goes beyond COP4813 because now we're going to deal with server-side code. Now, at this point, you may or may not have actually done server-side programming. But the bottom line of server-side programming is I can put code into the things that I'm serving to the client, to that user, that get translated by the server to do something and send something out. A good example is just throwing in code in an HTML file that reads a database, grabs data, formats it, and that's what goes over to the client. Well, how is that done? It's done with server-side code. And there's a lot of platforms that do server-side code. Now, you as a developer can pretty much do a ton of things server-side, can pretty much do a ton of things client-side. There's some things that you can't do client-side. That's what the server-side code is for. But what you've got to think about is, what am I doing on the server? What am I doing on the client? And understand that that communication between the server and the client is asynchronous, may be interrupted. Okay, so you've got to make, and you as the developer have the responsibility of understanding what's the reliability of the connection. How am I going to fail if I lose the connection? What is it that I need to actually make sure that the end user gets to see? How much interactivity do I need to do with to provide that user? How much bandwidth have I got to be able to use to take things from the server to the client? That's all your responsibility. That's why it's a lot of work to become that full stack developer, and that's also why they're very valuable programmers. Also, look at this. You've got a whole lot of languages that you might have to be working in. And the reality is that you'll probably stick with just a few that you work with on a regular basis, but you still got a lot to learn. And you'll be doing this for a long time. And as you're learning it, new things will be introduced, and the platforms and the environments are going to change while you're doing it. You've got to be dynamic and capable and intelligent and well educated. All those make for you to be a good developer. Go one level deeper, guess what? You are also going to be a database programmer here too. You've got to get the whole thing. And I'm just going to give you a few of the different types of databases that I commonly use. I really do like to use SQL Server most of the time, just because I like the T-SQL language, though I do like PL/SQL and Oracle, because I'm a purist in the database and that I actually like to have a layer between the data and between the actual web server. And that layer that I use in SQL Server and Oracle is the ability to utilize stored procedures. However, things like MySQL don't support stored procedures. So your interaction with the database is actually going to be at the level of writing SQL. If you don't know what I mean by writing pure SQL, then this class is well above the level of what you're going to be doing anyway. However, most people take this at the same time they're taking the advanced database class, where you're going to learn to do stored procedures. And you should have already had at least some classes in database where you've actually used SQL. Concept being, you got a server that throws a piece of SQL at a database. That piece of SQL is going to return some information that's going to then be formatted and served over to the user. And all those steps, the security, the connection to the database, the bringing up the information, the writing the correct SQL, formatting the data, to sending it out to that client, that's all you. That's all the full stack developer. Now, if it wasn't complex enough with all those pieces that you've got to learn, and why this is actually a great career, you've also got to think in terms of the architecture itself. Most stack developers either work for a consulting firm, work for a company, or work for themselves. Now, the ones that work for a company, the companies probably have already going to take into account the architecture. This is the architecture that they use. However, if you're an independent consultant or you're doing consulting for a company, which a lot of full stack developers, that's what they do, you've got to think about what's going to be best for your client. And you've got to take into account the cost, the availability, the support, the expertise, the maintainability, and the compatibility of all the languages, all the systems, everything that's in the middle. Because the reality is that your client's going to want to have an application that they can use now, and that's going to be able to be expanded to what they need in the future. And they're also going to be cost conscious, and they're going to be able, you may not always be around to help them out. So the support and what's necessary for them to be able to take their application in the future is all part of full stack development. Yes, there's a lot to it. So there's even more. So you've got to think ahead when you're doing the selection of a stack. And you've got to think in terms of the scalability. And you've also got to think in terms of the speed. You may be writing an application with just a little bit of data, and it may grow beyond a little bit of data. Again, part of the job. So a lot of the different common stacks right now, 2018, this is probably going to change, and this slide won't change, but you will actually be able to look up the different types of stacks. But these are just examples of different common stacks that people work in. And the students in my class choose, they select a stack, and then they defend why they selected that stack for their projects. But if you look at these, each of these stacks, you're looking at an operating system, you may be looking at a web server, you may be looking at a database, you may be looking at a language, and you may be looking at basically things on top of that language. They're all there. And as you can see, there's a lot to it, because these are just 5 common stacks, by no means all of the possible stacks that you could have. And then, if that wasn't challenging enough, you've got to deploy the application. Now, most deployable applications are now being set up in the cloud. You probably no longer have to worry about what servers are available at your place of work, because you can go ahead and you can lease the space on one of the cloud computers. And there's multiple platforms for doing that. What I want to get you familiar with is the concept. In this case, I'm just going to use Amazon as an example. This is Amazon from Amazon Web Services, which actually allows you to choose an AMI. And that AMI is going to include, if you do this correctly, all the pieces of that previous slide that you saw with all the different kind of stacks are built into the AMI, or at least they're built into the different AMIs that you're going to have that are going to be talking to each other, because it doesn't all have to be done on one machine anymore. So like in the case of EC2, which is Elastic Cloud Computing in Amazon, which would be essentially setting up a server, that server can contain the full stack of everything that you need to be able to do what you need to do. Yes, I understand this is getting more and more complex, and I understand, guess what? You're going to research and you're going to look into it. But this is a lifetime of working on this. You're going to be doing this for a long time, so you want to learn what are the best ways to do it. Then finally, you're writing code. And if you're writing code, you need to be able to manage that code. So let me tell you what I mean by code management, because part of code management is version management. Code gets different versions, but code management is more than just managing versions of code. It means things like, if you're writing code, you want to have standards by which you write the code. So coding standards can be as simple as saying you will always have functions that begin with a specific prefix, a specific name, and you're going to have space. You're going to use line breaks between each of the different lines of code. And you're going to use these standards for naming variables, such as maybe all strings begin with S, or begin with string, or begin with str. Those make it easier for people to come and take your code and move forward. And you're going to have, very likely, you might be working in a team, or you might have to plan for the time when somebody has to take over your code. So not only that, it has to be documented. And you're also going to have probably policies how the code is reviewed to ensure it's meeting the standards, and how the code is tested. Again, as you can see, a lot to it. So it's more than just a little bit. Now, I'm just going to give you one tool. There's plenty of tools that do code management and version control. Git is what we typically use in my classes because it's free and common. Now, that also means that you're going to have a place to put your code, not just on your local machine, but a cloud repository. So as we move forward in COP4834, as you start learning how to do Web Systems II, you will be using a cloud-based repository. I'm going to give you some ideas of different ones that you can do, but GitHub's one of them right there off the bat. That's possibly a very good one to use. Also, there's plenty of paid ones. So all of this. Now, of course, obviously, you're not coming in not knowing anything, but all of this is what I expect you to do, discuss. The best way to learn about different environments, different stacks, different tools is discuss them with other students, and I give you a discussion board to do that. What we are going to do, which will be a topic of another presentation for this class, is you're going to develop a CRUD application on the cloud with the full stack. And you can go complex or you can go easy. The bottom line is you've got to just demonstrate to me that you're capable of doing a full CRUD in an environment that is a cloud environment with a stack of which you understand all the pieces of the stack. No small order, but also what you've got to become a full stack developer. Thank you very much. This is COP4834. This is Ron England out, and good programming. Welcome to COP4834 and becoming a full stack developer.